Hey, so I wanted to show off something interesting that I did in the process of building like a suite of data and code in SQL to run tournaments and collect data on battles in competitive Pokemon in a tier that I run called ADV50. Um, but even if you don't play Pokemon and you're just interested in the problem statement I've got on screen, then this is still the video for you, as I don't really talk about Pokemon at all in this video. It's just interesting SQL. So the problem statement, as you see on screen here, is we want single elimination tournaments that are seeded. So the idea is that in the final, you've got the top seed against the second seed, and then so on the assumption, like 1 and 4, 1 versus 4, 2 versus 3, and so on, as on the screen, with the assumption that the higher seeded player would always win. Now, of course, that doesn't actually happen, and that's why you'd host a tournament. But this sort of is built to give, if all expectations are met, the marquee matchup in the final, for example, as sort of the motivation for it. And this is how I wanted to host tournaments for this competitive Pokemon format. And the way I solved it was actually pretty interesting, which is why I wanted to make this video on it, as something a little bit unique that people it's just a really fun little piece of code. So, well, I'll put the code on screen now. This is it, just in a position where we can just play around with it. But in the native world of the procedure that I'm using it in, if you want to take a nosy, sits in there in a slightly different way. Base the realization that helped me understand what I needed to be doing with this is that it's a hierarchical structure, first of all. So for anybody who's done like some basic SQL, they'll probably come across CTs and be told these are used for hierarchical structures. Now, for me personally, in like my job role and stuff, I've not actually had to use them in that way. I've used them in all sorts of creative ways, but not really with hierarchical structures very much. But in this instance, we do have one of some sort. It's a bit unique and mathsy, but it still is one. And the trick that we're using here to generate this is we want to generate each round of it. Although in theory, you could just generate a particular round of it with a where clause at the end. But for our purposes, we're going to generate each round of it. And we're going to basically start off with the 1 and 2 as the recursion, the first stage of the recursion. And then we can anchor it with the number of rounds that we've got. So for the one on screen, because it was practical to only do this many, it's got 3 rounds in it. It's got an 8-player tournament. Fun times. Yeah, and what I realize is that basically if we treat these, the 1 and the 2, the final round, as the columns in the first recursion level, then they become a single column in the recursion level down. So if we look in SQL here, if we just pull through, I'll just select star from this, so the recursion level will come through as well. On the first recursion level, you've got 1 and 2. On the second one, it becomes 1 column. And then we generate the match. And then we do the same thing on the third level and so on, up to as many levels as we want. We just change this variable to be 3 or 5 or 10 or whatever. Obviously, in my system, it sort of depends on how many signups there are. It'll then automatically choose a level, a number of rounds, and hits a recursion level. The trick with creating the matching numbers is quite easy to see when you look at just the number 1 on each round. So you see here, you've got 3, here you've got 5, here you've got 9. If we just subtract the 1, if we just look at what's in column 2, you've got 2, you've got 4, you've got 8. So basically, we've got a power of 2 here. We've got 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Yeah, and that's how it works. If we pull through, so to generate the second part of this, if we pull through, here's what's like the generated number. Here's what we get with the recursion level in each round. We've got 5, 9, 17, where these numbers come from. If we take away 1 from that, actually, because within the CTE, it's obviously looking at the layer below. So in this, it's working with 1. But then here, you need to work with 2. So for illustrative purposes, you see there we get the 3, 5, 9. So 3, that's what those add to. 5 is what they add to. 9 is what they add to. Because you've added 1 to 2 to the power of the recursion level. So that's how you get the matching numbers to come through. What did absolutely blow my mind was the fact that in SQL you can use 2 union alls in a recursive CTE and it just works. I don't know if that was intended. It's hard to imagine why someone would intend it to work that way, so much as not putting in something to stop it. Just maybe something like interesting to dig into for anybody who's looking at this from a SQL perspective. But it's not really important to understand whether it works. It's just the fact that it does work, I think, is just really super neat. And there you can see what I've done here. Yeah, we want to include number 1 and number 2 feeding into one column. So the 1, 2 from here feeds into this column here. The 3, 4 from here feeds into this column here. They all feed into the same column, then we match. And that's how it works. And sort of like how I came up with it was realizing that you had that relationship of like rows go into columns and so on. You can maybe sort of understand where that's coming from, not as easily from this perspective, but yeah, that's how I solved it. I've included the code in the description that I've used just for generating this. Yeah, that's kind of all there is to it. I'd note that also in practice, I also apply like a level of like bracket shuffling, which is a case of like, because I'll be hosting several tournaments, like one after the other, with similar participants, then you don't want to have the exact same matchups each tournament. So within like a small group of like 4 players, the actual order of their seeding is shuffled. But yeah, it's more of a specific use case thing for me. But I hope that if you're like hosting tournaments in Pokemon or anything else, and like if you're using SQL to do it in some way, then like this helps. There's of course probably ways of doing this in other programs like Python and so on that may be more practical if you're not like storing massive amounts of data in SQL and stuff as well. But for this project, I'm doing that, which has got a lot of nice knock-on benefits with the sort of analysis I can do that other tournaments simply can't boast of with the limited data that they collect. But anyway, that is the video. I hope you enjoyed. If you find this useful or interesting, please leave a comment. And thank you very much for watching. Drop a like and subscribe. Although I don't know that I'll be doing much more coding content necessarily. But, you know, here we go. But I hope you enjoyed this at least. Bye-bye.